we start finding these coordinates, we start needing to find the distance between them. And, if they're oriented horizontally or vertically from each other, I could basically just count to see where they are and know what the distance is. However, if they're lying diagonally from each other, which means, I don't have a common x coordinate or a common y coordinate between the 2 points, I'm going to have to figure out what its distance is. I can't just count. So what we do is we have this distance formula, which says d equals the square root of x squared minus x1. It's basically the difference of your x coordinate squared plus the difference of your y coordinate squared. So if I wanted to find the distance between 1, 3 and 1, 7, I would take the square root of 4 minus 1 squared plus 7 minus 3 squared. 4 minus 1 is 3. 3 squared is 9. 7 minus 3 is 4. 4 squared is 16. Which gives me the square root of 25, and the square root of 25 is 5. So the distance from 1, 3 to 4, 7 is 5 units. I'll do the same thing over here. D is going to equal, now it doesn't matter which order you subtract them. Okay, generally if I do the y coordinates in this order, I'm going to do the x coordinates in the same order. But that doesn't even matter in this one because of the fact that we are eventually squaring them. So if I do negative 2 minus 10 squared plus 1 minus 6 squared, negative 2 minus 10 is negative 12. Negative 12 squared is a positive 144. 1 minus 6 is negative 5. 5 squared is 25. So that equals the square root of 169. And the square root of 169 is 13. Now keep in mind, you're not always guaranteed to have whole numbers for these or integers for these. Sometimes you will have decimals. Sometimes you will not be square rooting a perfect square. It can happen. So don't get alarmed if you see that in anything that you practice along the way. It certainly can happen and oftentimes does happen.